Welcome back to Programming Kinect for Windows V2 Jumpstart. We're at module number 3, and we're going to talk about hand pointer gestures and speech. I'm Rob Relier, Program Manager on the Kinect team. I'm very excited to have Mark Schlesinger here. We're going to dig right in. I'm a Program Manager on the Kinect team focusing on hand pointer gestures and mostly the programming model. And I've, in previous lives, spent a lot of time with WPF and XAML. Mark brings a lot of stuff to the team here.
Hi, so I'm Mark Schlesinger. I'm focused on the interaction model and generally how we interact with our computers through NUI, through a variety of different sensors, kind of new ways of interactions. In my previous life, I've spent quite a bit of time on a variety of different shell teams, so I've worked through shell experiences and kind of transitioned throughout my career more towards input and especially new forms of input. And so that's what I've been doing for the last few years.
Cool. The module overview, we're going to be talking about hand pointer gestures. Mark's going to be focused on the interaction model that we've landed with Kinect for Windows and Xbox One. We'll talk about the programming model. We'll show you how the samples do it. We'll dig into some of the sample code. We'll build some from scratch as well. And we'll give plenty of demos. In speech, we'll give you the basics about enabling speech, show you a few samples, and then show you an experience that we've built as well that ties some of all of these things together. So hand pointer gestures provide great ways for users to engage with your user interface or your content. We're going to start by going into the interaction model. The video here, Mark, why don't you go into the interaction model here, the engagement. We'll show this video.
Yeah, so engagement is the word that we've used to describe that kind of initial moment where the user's telling the system that, yes, I want to engage, I want to interact at this point. So the model we've selected, as you can see, we have this kind of silhouette man that we've used as kind of a tutorial training example. He's raising his hand, it's an open hand, and there's a general orientation towards the sensor, which we are making the assumption that the sensor is located in a similar location to the screen. So the user is intended to be kind of, looking kind of oriented towards the screen and then raising an open hand. We wanted to build something that was extremely light and reduce the barrier because we understand that this moment, this engagement moment, is something that a user has to do every single time that they want to interact, even for the smallest task. And so if that moment has a huge barrier for the user, that's going to be a tax they have to pay for every single interaction.
Right.
So we wanted to make sure that that was very seamless, very natural, and very easy to perform in a quick fashion.
And we also want a great signal that doesn't fire, do false positives too often here. You don't want to see a cursor unless the user wanted to engage.
Yeah, that's a huge challenge that we've always had with this, is making that balance. That's really we'll get more into engagement a little bit more, and we can talk about that balance and some different approaches that you might choose to take for your application, depending on what you need and what your scenarios are.
So once you're engaged, you have a cursor, and now you can target. Tell us about targeting.
So targeting is a core input concept, right? Everyone is familiar with that. That's how you move your mouse around. That's how you indicate what on screen is of interest to you. So for us, we use a cursor. We've modeled our cursor feedback around the hand because it helps users to associate back to what they're actually doing. We'll talk a little bit more about that feedback as well in the later part of the deck.
Gotcha. And next we've got press. So you've been able to target something.
Yeah, so press is our selection model. Again, really focusing on trying to have a natural experience for people, and that's what we've seen as we've gone and worked with users when we've tested and asked people to perform a selection model with a gesture type air gesture experience, what comes natural, and press is really what stands out as what people really want to be doing as their natural interaction for selection. It mimics kind of the real world experience of the way we interact with different types of activation mechanisms in the real world. We've been pressing buttons on our mice, pressing with touch. It's just kind of pressing buttons, switches. It's what we as humans tend to like to do for selection. So that's the model that we've selected, and we'll go into a little bit more detail on that one too.
Great. And then panning and zoom. Maybe you can, as you talk about the panning and zoom model, also talk about the influence of touch on our experiences. So there's basically panning and zooming.
Yes. Sorry. And so kind of wrapping up the model for us is the panning and zooming. So we often talk about this as in terms of manipulations, right? And so here we use the grip gesture, so closing your hand, open to close transition, as kind of an indication of coming in contact, and then you're able to manipulate that object. So you can move it up and down. It's very similar to that kind of direct manipulation model of touch. Obviously you're not in direct contact, but it's kind of mimicking that concept where you can basically just feel like you're grasping the screen or grasping an object on the screen. And then you're able to freely move it however you want with that natural analog behavior. That's one of the things that really makes gestural inputs and both from Kinect as well as touch stand out, is that really analog, natural, human input. And so we wanted to make sure that really came through in our interaction model.
Great.
One more, I just want to add zooming on there. I didn't touch on. So we have zooming as an in and out motion. So again, it's as if you're grabbing the screen, you pull it towards yourself, which makes it come closer effectively, or you're pushing it away. So that kind of wraps up the basics, right? That gets you your basic model, which will allow you to perform, most tasks in any UI. So it's a pretty flexible set of small controls that, really can allow you to build just about any application.
Great. Let's dive in. So all of these services for hand pointer gestures are available for desktop or store applications. And fundamentally, you need to opt your application in to this input mechanism. And here we've had this technology in Kinect for Windows 1.7 and later, and we've continued to refine it in Xbox One, and we're bringing the latest and greatest to Windows now with Kinect for Windows 2. So let's start by looking at some of those concepts. We'll look at user viewer, engagement, targeting, and press inside of Controls Basics XAML. And we have 3 samples in the public preview. Controls Basics XAML for a store application, Controls Basics WPF for a desktop application, and we also have Controls Basics DX for a DirectX-based application that happens to be store-focused. Let's take a look. We're going to run Controls Basics XAML. I've got it pre-built and pre-installed on my application, on my machine. Once again, as Ben showed you in Module 1, if you ran the SDK browser, you'd find that and you'd install it and run it. So as you see in the middle, we have a user viewer, and it's got me recognized. It's green, and it's able to show that I'm a recognized skeleton. As I put my hand up, it will engage. As Mark said, we want to turn towards the sensor, lift our hand up, and then the engagement signal happens. And the user viewer is really important to orient the user. Maybe you want to talk a little bit about the user viewer. So
the user viewer is a great form of feedback that helps people understand what's happening in the scene. First of all, for developers out there, you're going to absolutely want to leverage something like that just so you understand what's going on as you're tuning and getting your experience to be tight. The tighter your experience is, the more you have it refined, you can start to reevaluate the need for it. But generally speaking, giving the users that understanding of what the sensor sees and how it's interpreting the scene is incredibly useful. I mean, if you just think about any other kind of camera experience you use today, even simple things like video conferencing with Skype, right? You get that feedback so that you understand that positioning, how you're positioned in the scene, what the camera is able to see, and it's really no different in this circumstance, right? Being able to understand what the camera is able to see can be, extremely helpful for users being able to self-diagnose and solve a variety of different issues that they might encounter.
Yeah, so I got a clue that I could engage here because I had a user viewer. I went ahead and engaged. You can disengage with that hand and engage with the other, and the user can engage.
And we've actually gone through a lot of effort to make sure that scenario works well. In particular, the switching of hands. That's something we commonly see users trying to do as they want to reach different areas of the screen where they might find it more ergonomically comfortable, or just a case of working for a while and you start to get a little tired and you want to switch. So that's definitely something to keep in mind if you're thinking about your interaction models and your experience, that users do like to switch between their hands as they work with the system. It's a very common behavior.
So as you see, I can naturally move through the physical interaction zone, the fizz, as we'll talk about in some detail, and move around the screen that way. In Controls Basics XAML, you can go into the experience for engagement settings. There are other engagement settings you can use besides the system. This sample shows you how you can do a hands overhead instead of hand towards there. So you can use different styles if you'd like. So the other thing we're going to show here is press. So I target a button, I get hover effects over it, and I start pressing in. We start seeing the animation, and we also draw towards the center. And boom, we get an animation, and we're pressed, and we've navigated. So let's switch back. That was the basic demos of user viewer engagement, targeting, and press. We'll dive a little deeper into some of those topics now. But before I do that, I'm going to show you actually how to just build that. What are the 4 or 5 lines of code that I need to add to the project, and the 4 or 5 steps I need to do to connect enable for hand pointer gestures a Windows Store application. Many of these are very similar for desktop applications, etc. So I'm going to, once again, say File, New Project. I'll happen to choose a grid application, a XAML app. I'll add my reference like you saw Jesse do in Module 2, enable camera and microphone capabilities, and then I'll add a Connect region as a container for root frame, and we'll run it. So before I write some of that code and before I do some of those steps, I'm going to talk about how you have to add hand cursor support into a XAML application. The typical structure of a XAML application has a window at the root that inside of app.xaml.cs is holding a frame, and that frame is navigating, you're navigating different pages into that frame. So that window and frame are always there for a Windows Store application, and the pages change. What we're going to do is we want to insert a cursor layer, or what we call a connect region, in between the window and the frame, so that every page has access to the ability to engage and interact with things. So we're going to add a control that you're familiar with from Connect for Windows 1.7 and later, called Connect Region there. We're going to add a Connect User Viewer that you saw earlier, and we're going to compose them together using a grid layout to layer them on top of each other. So that's the most code we'll write is just setting that environment up and customizing that. So sorry, jumped the gun there. Let me switch over to Visual Studio, and we'll do that. We'll say File, New Project. We'll choose a Store app, a Windows app. We'll choose a grid app. It'll be called App 1. The beautiful thing now here is if I go ahead and run this application, I have something that's touch-enabled and mouse-enabled already. That's a theme that you'll hear from us, is that we want to enable different input methodologies so that they're able to all coexist as the user wants to choose one of those things. So that's using touch to interact with this application. Let's go ahead and do this couple of steps. So the first thing I'm going to do when I want to use controls, I'll add a reference to Windows 8.1. We also support 8.0 if you're targeting 8.0. And I'm going to choose Microsoft.Connect.XAML controls. Windows Preview.Connect is what Jesse showed earlier. That's where most of the Connect APIs are. But basically, Connect.XAML.controls will depend on Microsoft.Connect.Toolkit.Input, which depends on Windows Preview.Connect. And it would automatically bring those other things in. So you really only need to choose the XAML controls. So I'll say OK. I did this in a different order than Jesse. You'll notice that I have some warning dialogues here. And if I go look at the warnings, which aren't showing here, it's telling me, hey, you can't use any CPU because you're using XAML controls and Windows Preview.Connect, which don't work on any CPU. I'll choose x86 so that it works in the designer nicely. There we go. We've got our references, and we're going to go into the app manifest. And as Jesse showed earlier, we need to add microphone and webcam capabilities because people can see, applications can see, and you need user permission for that. Now, that's a complete application. let's go drop Kinect region in here. So in app.xaml.cs, there's a little line of code here called Windows current content equals root frame. That's where the window and the frame get joined together. I'm going to create a few things. I'm going to take Kinect region, and I'm more of a resolve guy than resolving namespaces rather than typing namespaces in here ahead of time. I'm going to create a Kinect region. I just use a default constructor on that one. I'm going to create a Kinect user viewer. And I'll instantiate that as well. Then I'm going to create the grid to compose them together. I need to set a few different properties on the user viewer because I want to do some things like horizontal alignment. So I'll say horizontal alignment, I want to center it like we've seen in that sample. And vertically, I'm going to go put it at the top. But we've seen applications use different locations for those types of things. So feel free to innovate there.
Yeah, I don't think that that's an important thing. Put it in the layout where you like it. The one thing I would say is the bottom of the screen tends to be a little bit more accessible for, bottom of the screen is a harder area for interactions. It's right around where you're disengaging, where you're saying you don't want to interact with the system anymore because you're dropping your hand to not use it. So it also has more issues when people are seated because their legs are up and higher and start to get in the way of their arms. So the bottom of the screen is the area that I would say is like the lowest value for Kinect interactive items. So that's another good location that you can throw it into.
So because you couldn't put buttons there and have them very pressable, you'd put something like the user viewer there.
It's definitely an option.
Okay, gotcha. Okay, so I've written a couple lines of code here. I'll catch you up. We added those two elements inside of the grid, and we're going to set inside of the Kinect region, we're going to put the root frame. So we'll add that root frame, and then in the window, we're going to add the grid. So much like the slide there, we now have the grid holding the region and user viewer, and the region holding the root frame. So let's run this and see if I did everything right with our 10 lines of code, maybe. So we have a user viewer, first signal. Now, if you don't have a user viewer, that probably means you forgot to turn on microphone capabilities. So go turn on webcam and microphone again. So now I've got my user viewer. I'm able to interact. The cursor shows up. And I'm able to press a lot of controls. In V1.7, we had a few controls that were Kinect specific, like Kinect tile button, Kinect scroll viewer, etc. We're trying to enable, both in WPF and in XAML, a lot of controls, checkboxes, radio buttons, etc. But that's your code to build the basics. Let's jump back into the slides. So that's what we built. Let's talk a little deeper about engagement.
Yeah. So again, we kind of talked about the engagement model that we have built. So that's there in the system already for you. We put a lot of effort into tuning that balance of basically the effort and the barrier to get through versus the cost of a false positive. So we tried to find something that was very balanced, but focused on having a very efficient and natural, easy, low barrier experience to getting in there. Now, for your application, it might be something different, right? If you have a kiosk, for example, you're going to really want to be pulling people in. For you, you're going to say no barrier, right? Like, I don't want any barrier at all. I want people to just instantly be able to engage, be drawn into the experience. I never want anyone to have a problem. So you might choose a different interaction model in that circumstance. Maybe your application is a group application, and you want to have multiple people that are interacting all at the same time, doing things together. You might do an interaction model there where you're actually splitting up the environment, the play space, the room, right? To say, hey, people on the left are a part of one team, and people on the right are a part of a different team. So you have to think about your scenarios and what you're trying to achieve. And the big thing that you really want to be aware of is the cost of a false positive, right? So think about that impact. So what would it mean if a user was engaged in your system when they did not intend to be? The lower that cost, the more you can kind of reduce that barrier. The higher the cost, if you were in a commercial setting and the impact could be larger, then you're going to want to raise that up, and you might not even want to use our engagement model simply as a first pass, and then apply additional filters on top of that.
Gotcha. So there's a few APIs in Kinect region. We have a set one-person system engagement and set two-person system engagement. You can do up to 2 people. The interaction model needs hand state to be able to do scrolling, zooming, those kind of things. So we limit you to 2 people engaged with our default APIs. And then we also have the ability to go ahead and set manual modes. And so go look at Control Space XAML for examples in this build on how to control that as well.
I just want to touch on the hand state part. Just to be clear on that, like one of the big things we get out of that is removing things like this. Before we had hand state, it was difficult to clear out a scenario.
We don't use it just for scrolling. We
Right.
absolutely use it for engagement. Good
right,
point.
right, and that's really the thing. It's about getting these types of scenarios.
We don't want somebody
Yeah.
drinking a cup of water to get a hand cursor.
Right, right. So we've done a bunch of training, and so if we have that basically goes into it should go into an unknown state. It certainly should not be an open state, which is what we're looking for in that case.
Gotcha. So I'm going to show a little demo here, but Mark, why don't you talk a little bit about the fizz and the shape we ended up with, and the fact that there's 2 of them.
Sure. So the fizz is the word we use for the space, that mapping of my hand to the screen, and which stands for physical interaction zone. And what we've done is we've tried to build the most ergonomic, user-friendly, and adaptable experience. Because remember, you have to think about different shapes and sizes of people, right? So what works for you as an individual may not work for someone else. And what we've done is we've gone with a bit of it has a bit of a curve to it as it's close to your body. As you'll notice that if you move your hand around, like you'll see my hand kind of pulls in naturally as I go from side to side. So that gives it a very ergonomic feel to it. We do support going kind of outside of screen space, so you can do things like big pulls for scrolls. And as we go outside of screen space, that curve falls off because people don't grab like this, right? There's a certain point where we have that curve and we don't think about it, and then there's a certain point where we start to kind of map back to a straight. So we have a space, it's around the user, it's placed in a location where the entire screen should be very ergonomic to get around. We definitely find that having that kind of anchored experience really helps people, especially novice users that don't have a good sense of gesture and where they might start to get into problems. Having it kind of anchored to the person in a consistent location builds muscle memory, as well as giving people a good starting point, right? So that they don't get stuck in places where they can't go and reach a part of the screen. It's built per hand, so the fizz for my right is kind of over here, and then if I lift my left, it shows up on this side, again for that ergonomic purpose, right? If we put it dead center, first you end up with a lot of occlusion problems that make the sensing more difficult to do, and then you also end up with these really strong cross body motions that were required, which are not very ergonomically friendly.
So the core thing from the fizz is we're mapping the interaction of your hand in one physical interaction zone or the other, and we're trying to give you a stable targeting point. So we're giving you X and Y. We also want to know Z. So I'm going to show you a little bit now about a demo here, showing you a little bit about Kinect Pointer Point. Now, you might have heard of Pointer Point before. Pointer Point in Windows 8 and later provides great capabilities for understanding mouse and pen, mouse stylus and touch. We are building on top of Windows 8, so we have a parallel API space, and we've modeled it just after Pointer Point. We call this Kinect Pointer Point. So first of all, this sample here that you see, it represents a little monitor, and as I touch different parts on the screen, with several fingers, it shows you all the different points where they're relative to the monitor. The blue is the monitor. And so that's touch. If I move the mouse around, you see where it is relative to the monitor as well. The signals come in off of pointerpoint.properties.position. I'm sorry, pointerpoint.position, and that gives you the X and Y. If you switch over into Kinect, you'll notice right now, as you see me in the user viewer, I don't have my hands in the fizz. I'm kind of below the fizz. If you see my hands raising up, you're seeing, there's really a circle there. So my hands were really, I wasn't engaged. There is no cursor, except for the mouse cursor in this application right now. And as I lift up, eventually I'll get an engagement signal. There we go. We'll engage, and we see we have a hand cursor, and I move from the top right, and I can reach the whole screen comfortably here. You'll see I've got two pointer points per person coming here, and one of them is engaged. It's the green one, and as I leave the screen, as Mark said, I can do things off screen, so we can do great scrolls from the side. I can go ahead and move over there, and that's where you see pointer point unclamped position is showing you, and you can get that raw data. But we clamp to the screen.
Yeah, we do clamp to the screen, right? And so the other thing we get with that is you get this kind of bounded targeting, right? So anything now at the edge of your screen, right, has a somewhat infinite size to it, right? Because as Rob puts his hand over to that edge, the cursor is going to be bound to that edge, and you still know that he's continuing to move there. So if he wants to do a manipulation, it can still influence things. But if he goes and has his hand at the edge of the screen and he does a press, for example, he can not move any further to the right because he's already at the edge. So that button effectively has unlimited size in that axis, in that direction. And so you can put important buttons in the corner and do kind of a gesture slamming experience where, if you look at like
in the top left corner or the top right corner.
Like Xbox One, we have our back button there. And because it's in the corner, you can really just slam into the corner with either hand, and it doesn't require much targeting because you can just overshoot.
So you can't see this behind the picture-in-picture, but I'm just clicking the details button up there. And you can see some of the data that we have on pointer point, on the Kinect pointer point. We give you the Z value, or hand reach extent. That's usually from 0 to 1, a little bit beyond that as well. We give you 3 bits of data that let you correlate it with other Kinect signals. Body tracking ID, hand type, and body time counter allow you to correlate it with the body frame source, the body frame reader, with the bodies that you get that Jesse showed you in Module 2. So if you want to correlate what is the user doing with their cursor versus what they're doing with the body, you're able to tie those 2 signals together. Close that application. So I'm not going to go through the details here, but you can quickly see on the PowerPoint here, we were showing off position, unclamp position, hand reach extent. Press extent is also a Z value, but it's affected by buttons that you're pressing over, and we allow you to correlate with the NUI data.
Press. Yeah, so now getting into press, I think we have, is that a question on the screen there? Press relative to shoulder joint. So getting into the details, so it is, but it's not just that. There's a lot more going on there. So we do have press is relative to the user's body, and we do a smoothing on everything, right, to make it simple for you guys to use, so you don't have to worry about any kind of bumps in the signal. And we do a bunch of smoothing on that that has a basis in the shoulder to give you that extent. Now, there's a bunch of other things, though, because the UI is important, right? If you only have one giant button, well, the needs are a little bit different than if you have a sea of tiny buttons. We recommend a minimum size of 208 by 208 based on a 1080p layout. And that gives you a good size button that basically is something that we targeted for a high level of success. If you go with larger buttons, they're easier to target and easier to press. If you go with smaller buttons, you're going to continuously increase the effort required from the user, but it is always possible. We actually do not prevent it from happening. It's just going to start to become more and more challenging for your users. So we recommend you stick with larger buttons. We do help the user as they press to pull them in. So at the beginning of the press extent, it's very forgiving and doesn't do much of that because we want to make sure that we're not misinterpreting your targeting action as a press, and we don't want to accidentally start pulling you into locations. But as you start to push in, we will start to help assist and bring you to the button that we believe you've been trying to target. We reset press every time you cross button boundaries. And there are other ways you can reset press as well. You can cancel out of it by moving very far off to the side, which would be similar to what you would find with many other input modalities.
Cool. And then you mentioned the top left, top left corner, top right corner, and left corner are easy to slam and press. One of the things we do with the back button there is we adapt to a smaller size. The back button is small, but we make it a huge hit target to make sure users will have success there. And on the slide here, we talk about a property on Kinect region, an attached property exposed there called Kinect Press Inset that allows you to say, hey, yes, I know that this button is hit testable for 208 by 208, but I'd like you to ignore the top half and the left half and just attract towards the bottom right. And so you're able to have a higher hit test zone without having to have a colored area.
Yeah, absolutely. Feel free to play with those types of concepts to make your layouts kind of as effective as they possibly can be. And the press attraction, you'll also notice, it doesn't always pull to the center of the button, because if you have extremely large buttons, that can be very jarring for a person, where it pulls all the way across the screen. So there's some flexibility there, and we really only pull 100 pixels in. So in a 208 by 208, that effectively means the center, but it's not always the case.
So we're going to hold these. There's a few questions coming up. Let's handle one now. Can we support dual hand input? The samples don't currently support dual hand input, but the signals are all there, and we can definitely evolve the samples to show you how to do that or work with you on the forums. The fizz can't really be changed. However, you're able to, map it to other values if you'd like. So you can still pay attention to values outside of the normal, the unclamped space.
You can think of the fizz as really just that mapping of the human body and their hands, to positions, right? Because we give you that unclamped information. You really get to see, you can sort of make it bigger through that. But again, we've built it relative to the person. A 100-foot display, it's not like you can move, you move 100 feet to interact with it, right? Like, my arms don't go 100 feet. So, if you wanted to have something really large, you might want to rethink the model a little bit, maybe the user's position has some impact on that, where they're active within that 100-foot screen, and then the relative motion is kind of driven off the fizz.
Cool. So we've got some cursors here that are an important part of the model.
Yeah, so feedback is critically important for users, right? They need to understand what's happening, and they need to understand basically progress, and am I over something active? Am I making progress towards pressing? Again, trying to stick with that natural model, we've done our feedback kind of in line with if you were pressing your hand up against kind of a piece of glass, and that handprint kind of concept. So you see there's normal, that's I'm not doing anything, I'm just targeting. Press progress, you can see as the fingertips and the palms start to come in, and then as you keep pressing, that's showing that you're moving towards a full press extent, which is a fully white hand in this case. And then at that moment that you've kind of reached that full press extent, we kind of have a celebration there, as I like to think of it, which is kind of represented in this press down animation. So that's a straight animation that's not based on user motion right there. It's to let the user know, hey, I've made it. It's that moment of contact. It's the impact. So we have that impact, which kind of creates that little bubble out. And then we actually also go through the press progress, and we go back because there is another component to this, right? It's not only press, but we also have a release. That's very important. It's very important for disambiguating the user's intention. It makes it much easier for us to understand that the user really wanted that versus some other action. I mean, there are lots of things that look like presses. If I have my hand up like this and I simply drop it down, I'm moving very forward in Z as I just simply go to rest my hand. And so that pullback really is a strong signal that helps you understand that, yes, I did want to press that, I wanted to press that button, and I'm confirming it. So remember that it is both a press and a release for this model.
Gotcha. So we're going to dive into zoom and scroll real fast in controls basics. And if I, once again, engage, I'm able to grip, move back and forth. I can move way off screen. I'm moving way to the right. I go pull, and I'm able to start the scroll from off screen. The cursor doesn't move right away, and I'm able to have big content scrolls. I can also scroll with inertia, flinging the thing, and I'll quickly show zoom, and you can talk to it. Here we have a zoomable photo. I will grip, and he said to zoom in, I pull closer to me, and I can go ahead and scroll around, and
we take a lot of concepts that you might have seen before, with touch, with kind of rails. So you can basically create zoom. All of the manipulations, right, have rails. So you can kind of bias towards X, Y, or Z motion. And bias isn't the right word. It's really
restrict to,
yeah. Right. So you can restrict to any of those, or you can have all of them supported, and allow people to kind of flip between. But it really will help people to be able to have that kind of restriction, because we very rarely move in a single axis at any given time. So being able to just move in one for a lot of, especially UI, is going to be important.
Gotcha. So let's talk about what's in this preview release. We have support in UI frameworks for XAML, for the Windows Store, and for WPF on desktop. DirectX is also supported with a sample in store. We also have native APIs, but we don't yet have a sample, the higher level sample for that. If you're interested in such a thing, please work with us. So fundamentally, there's this API at the bottom, which provides Kinect data. Windows Preview.Connect provides those pointer points. There's a Kinect Core window class that has a pointer moved event. It provides Kinect pointer points. And there's Kinect gesture recognizers that understand what our press is and what our scroll is. So the API and the architecture is very similar to touch, mouse, and pen in Windows. Then we have a layer called the Toolkit Input layer, Microsoft.Connect.Toolkit.Input. And this provides some helper classes like Input Pointer Manager, Pressable Model, and Manipulatable Model for some of the higher levels to have a simpler time of coding these complex interactions. So the XAML controls library is built on top of that Toolkit Input layer. And that's where we added the ability to do cursor rendering. That layer is responsible for doing hit testing for wherever the point is to understand what pressable things and what manipulatable, scrollable, or zoomable things are underneath the cursor. And they route those Kinect pointer points via the Input Pointer Manager. But really, all you need to know is those top couple lines of code to drop it into Controls Basics, like Controls Basics XAML does. Now, the app just hosts Kinect region. Controls Basics DX, go take a look at the source code there. If you're interested in some of those lower levels, you'll be able to see it working without a UI framework, of course. And then in the WPF example, we have a WPF controls framework as well that has Kinect Region and Kinect User Viewer. So take a look there. There's a number of other ways that, beyond working with just menuing and interacting with controls that you can do. You can interact with content, and I'll show you a couple we'll show you a couple demos there. One thing you might be able to do is rotate a 3D object or navigate a camera through 3D space. And we'll show you a sample called Hand Pointer Joystick that allows you to interact with content in natural ways. We'll also show you scrubbing a video when we get to the speech section. So quickly, let's do the Hand Pointer Joystick demo. Now, you'll notice I'm leveraging, if you could do picture-in-picture, please. I'm leveraging the interactions and manipulation. It's the signal here for the joystick, which is in 3 dimensions, is leveraging my beginning of a manipulation. So I start the scroll, and that's my 0 point for X and Y, and for Z, it might be my 0 point, but it isn't always. So here I'm able to move X and Y as I move up and down and around. And as I push towards, sorry, this sitting position isn't the best way to demo this right here. But I'm able to go ahead and see another orientation here as well. But this would be an interaction that I could use to walk through 3D worlds, perhaps.
Yeah, and one of the things I really like about what Rob did here is a great example of kind of the process you might be going through as a developer. So Rob started with the idea of, hey, I want to create a virtual joystick. But what you just saw in that app was not really probably the first thing you would think of as a virtual joystick, but being able to build something like that that helps you understand your signals and how the experience feels, that's essentially, I mean, it's kind of, that app is almost like a debugging tool for the final experience. And I really encourage you guys to go out there, build those types of things, build those tools that you need for your scenarios, that help you understand that experience, that input, and how things feel. Because that's something that I think if we were really developing that scenario, we would spend a lot of time in that kind of app to get the feel down right.
Right. So we're going to switch over now towards speech and talk about another important input mechanism that Kinect enables. Speech on the Xbox One with Kinect and both Windows 8 and beyond with Kinect have a number of things in common. So Xbox has one model basically for being able to use global commands, and you say the term Xbox and you're able to access global commands at that point. There's another model for interacting with the current application with the user interface, and then you say Xbox Select, and text turns green, and you have prompting and a great experience there. And then you can also have inexperienced commands that games or applications have app-defined grammars that provide great shortcuts for users. In Windows, in Kinect for Windows, we don't have global commands in Kinect for Windows 2.0. We allow you to have whatever engagement model you'd like for app commands. We're going to show Kinect being used, and that might be something that works for a number of applications, but you could feel free to use something else. And you also have the ability to create grammars, both programmatically or via declaratively, to define these grammars that allow a user to steer through your application. Speech has gotten great support in Xbox One, and it's great to see people enabling their Windows applications via speech as well. This is available to desktop apps only in the K4W2 timeframe, and it's an opt-in mechanism here. The speech engine isn't there yet in the Windows Store at this time. So I'm going to, in the interest of time, I'm going to jump ahead not to Speech Basics, but to well, actually, let's go ahead and just do Speech Basics real quickly. Sorry. So Speech Basics is in the SDK. It has a basic grammar that you can control a turtle with. You can say turn left, turn right, back, forward, and we have UI prompting, etc., to be able to control that. Go take a look at the code and learn how to create your own grammar. We built a richer experience that we'll talk about now as well, and that's just a little media demo. So this is a little media viewer. You shouldn't be getting audio here. Don't be confused if you do. This works with the mouse. Excuse the developer UI here. But we also made this. Oops.
Rob gets lots of offers from our design team for jobs.
Yes. We're also enabling this for touch and with voice as well. So if I say the word Kinect, it brings up my UI, and I get some prompting up above, and it tells me I can use green. I can say the green words. So I'll say Kinect, next, and it goes to the next video. There's Ben. I can say, when I don't have any UI here, I can say Kinect pause. Kinect pause. There we go. And I'm also able to use hand pointer gestures here as well. So if I bring this up, I'm able to click on the giant play and pause button here that you can't see, or click on any of these controls. I can also do something that we did, that Mark and team designed here in Xbox One, and that's the ability to grip and begin manipulation. In Xbox, we went ahead and basically start scrubbing the video. So we have a real fast way to go jump to wherever we'd like to by using those manipulations. Let's take a quick peek at some of that code. Maybe, Mark, you want to talk about
Yeah, while you're bringing that up, I can just talk a little bit about a few of the interaction experiences there. So one thing for speech, make sure that people understand what you recognize. You're going to want to have that for your own debugging needs, but users are also going to want to have that kind of feedback. It builds confidence and helps people understand what's going on in the system. There's nothing worse than a system that feels like it's possessed and it's just doing random stuff. So you want to make sure you give that feedback, and Rob had that example there as whatever was actually recognized was shown in the corner. So that's going to help a user just in case that they're having a little bit of trouble with recognition and maybe two words are sounding a lot alike. They're going to want to know what is it you thought that I said, not just have a screen flipping out or how to address that issue. So very important part of user feedback. Users also always need to know what they can say. That's a big challenge with speech. I mean, we as humans use speech as such a large part of the way we interact with the world, but when you don't know what you can say, when your vocabulary gets limited, you need to be able to provide that information to the user, right, so that they understand, hey, these are the commands I can say. So in the Xbox world, we did a see it, say it model where we, highlight words in green after using that keyword.
Yeah, let's jump to the code, and you can talk to this here. I've got two little bits of code that I modeled off of Speech Basics, and I just riffed on it a little bit. So I went ahead and said, hey, let's create a basic grammar. And the basic grammar fundamentally says, hey, you can say the word connect, or you can say the word connect play, connect pause. So that's when you have nothing showing. And once you start getting UI up, there's a listening grammar, I call it. And the listening grammar allows you to say connect plus the word in the button, connect play, connect pause, etc. You can say stop listening. And you can also, if you're doing fast forward, you can always kind of cut it off with play. But you were saying the grammars, you go ahead and...
Well, yeah, so it's letting people understand what they can say. I mean, that's an existing model we've used, so it's easy to leverage that, and people may have some experience from the Xbox with that. You can try other models, but that's just something that's already kind of been set out there. Another thing that Rob kind of touched on there was that active listening mode. So the same kind of problem you have with speech that we have with gesture in terms of engagement and understanding user intent. But once you have that user's expressed engagement, they've said connect or whatever your keyword is, you're now in a dialogue just like you would be with a person, right? Like I might, if I was going to talk to you, I might say your name, I might wave at you. But after we've kind of established that engagement in our conversation, we no longer go through those things because we have each other's attention. And you can do the same type of thing with your speech experiences. So, on the Xbox, we go into an active listening mode after you've kind of interacted with the system, and we give you a bit of a window where you can keep firing commands. And you don't have to go through that active engagement anymore. So, and that's very useful, especially for things like, a media experience, right? If I'm going, rewind, I want to be able to say play instantly. I don't want to have a big barrier there. So, think about those kind of different modes, right? And that, again, that barrier, that engagement barrier of, am I trying to interact? What's my intent?
Gotcha. One really important thing to understand when you're trying to run or build new speech code with Kinect, you need to, at compile time, at development time, you need the Kinect SDK installed. You also need the speech platform SDK v11. Usually x86 and x64 is good to install. Plus all the runtime requirements, which are in the right column here. You need to have the Kinect runtime installed, the speech platform runtime v11 as well in those flavors, and there's some language models. And this has changed a little bit from v1. It used to be that when a default user got installed with the Kinect runtime, the English language model was there. Be aware that that's changed now, and that your application needs to bring forward these runtime requirements as part of their setup. So it's an important part of your model here. We've been excited to talk to you about hand pointer gestures and speech. We'd love to take a few questions if there's questions from the audience. There's a bunch of resources, once again, as you've seen in other modules, as we're waiting for a few questions here. So one question here is, can the speed of the cursor be controlled in the Kinect region? If you want to change the speed of the cursor, what you're effectively doing is you're saying you want a smaller fizz or a larger fizz. So yes, you are able to change the ratio if you'd like, but we've tuned it pretty precisely at what we've got.
Yeah, that's a dangerous place to go, just in the sense that I find typically the people who are more attached to the technology go smaller, smaller, smaller. And the smaller you go, you're introducing more noise because you just have less motion, less signal in there. And it might be usable for really advanced users, but as you start to just go grab someone off the street, they're going to have a more and more challenging time. So we really tried to balance the precision, and the quality of the input with the amount of motion required. And in all honesty, if there's something I would try to do, I would rather get more precision out of the system, and I would want it to actually be bigger. If I could, you just start to get into ergonomic issues, and so that's really what limits us.
Gotcha. So it's physically possible, but whether or not you want to do it, be careful.
A little caution.
Yeah. Can you use the Kinect region in C++? Yes, you could. Kinect region is actually Kinect region, and the XAML controls are written in C++ in WinRT. You are able to use Kinect region in C++ XAML applications. If you're trying to do C++ and DirectX, those you don't have a UI framework. There is no Kinect region there, but we provide in Controls Basics DX a lot of examples on how to do your hit testing in your DirectX application and map that appropriately into the lower input layer. We currently don't have Kinect controls in WinJS or in HTML applications. Let us know about your interest in that space. We're definitely interested in listening. It's definitely possible to build that on top of the toolkit input layer that we've provided for WinRT in the lower layers. So once again, I'm going to, let's see, can Kinect be used with Cortana? Today, Kinect and Cortana aren't able to be used together. Are there any more questions? Okay, I think we're running out of time here. We're happily moving towards a meal break, as everybody's excited to eat up after getting a lot of great information for these 3 hours, hopefully. We're going to be moving to Module 4 after the meal break, and Module 4 once again is going to be covering frameworks, creative coding, Unity, etc. A lot of exciting things there. Thanks very much, and we'll see you online.
In an hour, right?
Yeah, in an hour.